Hi there. First of all, I'd like to thank everybody for the help and support and advice provided. It really is very much appreciated. And in particular, a couple of guys. First of all, Simon Miridew. He provided me with some information regarding ISO system of limits and fits. And in my previous video, I was trying to place some bearings in the body of the farm boy. And basically I just guessed what size those should be, the outside diameter, and it seemed to work okay. But this ISO system tells you exactly what type of tolerances you need for all different types of fits. So really interesting. So in the future I might sort of introduce that into a couple of videos. Also to James Chaff. And now James sent me a homemade ignition system which utilises a coil out of a car. And it's very timely really because I'd only just bought myself a little spark plug, and I was thinking I know nothing about ignition systems, so that's fantastic. So I'm really looking forward to having a go at messing around with that. Now in this video what I'm going to be doing is machining the crankshaft for the Farm Boy hit and miss engine. Okay, so the drawing shows the crankshaft being made out of one piece of tool steel. Now I've not a cat in hell's chance of making this out of one piece of metal. So what I'm going to do is I'm going to fabricate it. So I've got some silver steel rod here, which I think is the same as tool steel. So this is 3/8 of an inch in diameter. So I'll show you what my plan is. So for the crank web, I've already sort of partially machined this, and what I've decided to do is to turn the sides down to 5/16 of an inch and leave the centre a width of 0.550 of an inch. So that actually means that when I assemble this, I can push these crank webs up to that point, and I'll be, damn certain that the distance there is 0.550 of an inch. If I wasn't going to do that, and if I sort of left these outside edges the same diameter as 3/8 of an inch, then on assembly it might be a bit more difficult. So that's sort of my plan. So what I'll do with the crank webs is I'm going to Loctite these together, I think. So the top hole, which I've marked, will be drilled and reamed to 5/16 of an inch, and the bottom one will be drilled and reamed to 3/8 of an inch. So I think I'm going to do that on the milling machine, and I'll get it set up, and then I'll get back to you. Okay, so I've already used an edge finder to find position, and I've used a centre drill, and that confirms that my original scribe lines were in fact correct. And what I'm going to try and do from now on is, rather than use a normal chuck, is to use an R8 collet chuck to give me more accuracy. So this is a 6mm drill bit in there at the moment, and just to demonstrate how accurate that is, the gauge is just fluctuating around about 1 thou, so it's only 1 thou out, which is pretty good for a little machine like this. So what I'll do is I'll first of all drill through with a 6mm drill bit, and on this one here I'm going to drill to 23/64, and then I'm going to ream to 3/8 of an inch. So I've actually moved the reamer quite high up in this collet chuck to make it more accurate. Okay, so I need to repeat the same process for this other hole, but I'll open that up to just 5/16 of an inch, but I'll do all that off camera. Well, that seems to have worked out okay. So what I need to do now with these crank webs is to create a boss there, and also put a radius on each end. And to do that, I'll set up the rotary table on the milling machine. So I've centred the table, and I put the piece in this little vise, and this is a piece of rod 3/8 of an inch in diameter, and I moved the rod into the hole, centred the vise, bolted it down, and now I know that this hole is spot on centre, and it's on the same centre as the rotary table. So what I need to do now to create this boss is I need to put a cutter in here, and I need to position the edge just at the bottom, and I need to take off 30 odd thou. Well, that's 32 thou taken off. What I didn't sort of appreciate is this handle is hitting the column at the back. But I think I've managed to get away with it. So what I'll do off camera is I'll just finish this piece off here, mill this edge here to the same depth. And now I just need to put a radius on this end. That looks pretty good. So I need to put a radius on this other end here. So what I'll do is I'll follow the same sort of principle, but I'll centre on the smaller hole and then cut the radius in a similar way. But I'll do all that off camera. Well, the crank webs certainly turned out okay by the looks of it. And I did realise when I looked at the drawing in some detail that there's a little boss on the inside there that needed to be machined. It's only 13 thou, but I did that in exactly the same way as I did the outside ones. So what I need to do now before I sort of glue it all together is I need to cut these keyways. So I'll mark them up and then I'll go over to the mill and have a go at cutting them. Okay, so I've marked up the keyways and I've placed the shaft on these V-blocks between this Type 2 vise from Archeoro Trade. This is a 90mm wide vise, which is a big bit large for this milling machine, but it works out fine for this application. Now, a while ago I made some sort of limiters for the x-axis, and I don't know whether you can see it, but there's one in there and obviously one here, and they're limited in terms of the travel, so they're adjustable. You can move them wherever you want really, and I've set them so I can just go between the two stops, and that's exactly set where my marks are. So rather than having to look at the DRO every time to see, you know, if I've come far enough down on the x-axis, I don't need to do that. I can just keep on going between these limits, and all I need to do is to start cutting at a depth of 1/1000 of an inch until I get to 64 thou. So that's the plan. Oops. There you go, I've broke the cutter. It just goes to show that 1/1000 at a time is too much for a little 3mm diameter cutter. Okay, so in hindsight I should have probably plunged cut with that 3mm end mill. But anyway, you live and learn. Now I've not got another 3mm end mill, so I'm going to have to send off for some. So what I'm going to do now is I'm just going to use this 3mm, in fact it's 1/8 of an inch drill. So I'll drill to a depth of around about 64 thou, and then I'll move down a bit and repeat and carry on like that for the moment. Well, I'm certainly not happy with that. The drill bit wandered off slightly. So what I'm going to do is I'm going to wait until I get another 3mm end mill, and then when that arrives I'll use downward cuts instead of sort of side cuts. Okay, so I had a bit of a rethink and I decided to use a little centre drill. So I've gone down the line with that. So when that 3mm end mill arrives, I should be able to tidy that up. So I'll repeat the same process on the other side, but I'll do it all off camera. Okay, so the replacement 3mm end mill has arrived, and I've started buying my end mills from APT, Associated Production Tools. I think they're based in Scotland, and I've had a couple of them before and I've been sort of reasonably impressed, to be honest. And also the good thing is they generally deliver the following day. Now, even though I've already centre drilled, I'm going to start off plunge cutting. Well, that looks pretty good. So what I'm going to do now is I'm going to cut sideways 1/1000 at a time until I get to that depth of 64 thou. But I'll do all that off camera. Well, I never thought that milling a couple of slots would be so time consuming, but I got there in the end. Shame about that little mishap there, but Anyway, never mind, it'll be under the flywheel. So what I need to do now is, well, I've marked this end here, so I'm going to take it apart, then I'm going to use some Loctite 638, reassemble it again, and I'll have to do all that off camera because it's quite fiddly, and then I'll get back to you. Well, I could absolutely kick myself. When I assembled it, I didn't get the keyways exactly on the centre line of the crank webs. And I now realise that these keyways should have been machined after assembly, because I could have put that in the vise and then machined exactly in line. And I think with them being out, I think it could introduce some problems later on. So I think I've got two options here. I either try and recut some deeper ones, or I take it apart and put these incorrect keyways at the bottom and assemble it and then cut some more. And I think I'm going to go with that option. So the only drawback with that is I need to apply heat, and I do intend to actually pin these, so I'm not sure if applying heat is going to harden this. But anyway, that's my plan. I'll take it apart and try and recut them. Well, I managed to take it apart okay, using a bit of heat, and I've reassembled it using Loctite 638, and I've put the old keyways underneath here out of the way, so the new keyways will be cut up here. So after assembling it, I've put some pins in, and I'll snip these off and finish off with a file so they're not overly apparent. And then what I'll do, before I cut the keyways, I'll cut this middle bit out with a hacksaw. Hopefully I'll get the right one and I won't cut this piece out, but who knows, anything could happen with me. So here I'm just cleaning up the inside faces. Well, I've refined my technique for cutting these keyways. So having set the limits on the x-axis, I've then used a centre drill to drill to a depth of 64 thou, and I've moved the x-axis along 50 thou and then repeated and gone right along with the centre drill. Then what I've done is I've replaced the centre drill with the 3mm end mill, and then I've followed exactly the same process but plunge cutting with it. I've not actually done that here yet. And then once I've done that, I'm then going down 10 thou at a time, just across and back and cross and back until I get to 64 thou, and that seems to get a really good result. Well, that turned out pretty well. Happy with that. And I think all I need to do now is to cut these angles here. So I need to cut a 25-degree angle here. And the way I've set this up is I've used a sine bar. Now this is a 2-inch sine bar. So the sine of 25 degrees is 0.4226. Multiply that by 2 and you get 0.845 thereabouts. So what I've done is I've put some slip gauges under here, 0.845 of an inch, and that should give me an angle of 25 degrees. Now just to double check that, I've got this cheap display thing, and that's calculating the current angle as 0.16. So in theory this should measure 25.16. Oops. .29. Well, I trust my sine bar as opposed to trusting that. So if I take that off, and then I've just put this parallel on here, just to make sure that that edge is parallel with that, and it is. It's at the right angle, even though it might not look it on the camera. So having done that, it's just a matter of just cutting this edge off here until I get to this line here. Well, I'm cutting in 10th increments, so it's going to take a while is this, so I'll continue off camera and then I'll get back to you. Well, that turned out okay, so it's just a matter of switching it round and repeating the same process on the other side. Well, that was certainly eventful, and I can't believe that I milled those keyways in the wrong sequence. But anyway, it was good practice doing them again. And it was also great messing around with that sign bar. I love stuff like that. But anyway, it seems to turn out okay. I've had to take a few thou off the insides of the bearings for it to fit in, but it runs very freely. I mean, obviously I need to put some oilers in the top on assembly, but I'm very happy with the results so far, and I hope you'll like it too, and I hope to see you later.